Good day, everyone. We are back on our discussion on the Philippine fishing ground, or the Fish 150. So in this session, we will be talking about bathymetry. So in this module, we will be defining what is bathymetry and what is the objective behind it, and what are basically the techniques that are used to assess the bathymetry of a certain fishing ground. So please also note that we are not only focusing the fishing ground in the marine water areas, but also focusing on the bathymetry profile of different fishing grounds, including the inland fishing grounds. So again, our topic for today is bathymetry. So what is this bathymetry all about? So pag sinabi nating bathymetry, it is the science or the study of underwater depth of the lake or ocean floors. So meaning to say, when we deal with bathymetry, we are focusing on the underwater depth of a certain body of water. So here we have in this figure, you can see that there are different color variations between the areas. So this is basically just a profile of a certain ocean floor. So pag nakikita natin dyan, merong may pink, may blue, may yellow. So in each of the color variations, there are specific depth level or depth of a certain water level. So that is the science of bathymetry. When we compare it to the science of paleobathymetry, paleobathymetry basically is just the study of the past underwater depths. So what happened before? Why did it form like that? Why is it that there are formations like this one? Why is it that there are slopes? Why is it that there are trenches? So para masagot ang tanong na yan, you deal with paleobathymetry. So this is the difference between bathymetry and paleobathymetry. So I hope that's clear, right? And here, the objective of the bathymetry basically is just to show the topography of the ocean floor. Ano yung tinatawag natin na topography? Ang topography is basically just, excuse me for a while, okay? So topography, say for example, ito yung contour in a certain ocean floor, no? Pag sinabi natin contour, say for example, ito yung tinatawag natin na water level. Say for example, this is the seawater surface, no? Ito yung surface ng water natin. And then there are you could observe in certain different aquatic environment na magkakaiba yung mga water depth, no? Yung kalaliman ng ng ocean, ng sea, ng lakes. Now say for example, this is the ocean floor of a Lake Lanao. Makikita natin sa Lake Lanao, near the coastal areas are shallower areas, no? Mabababaw yun sila. Okay? So mabababaw yung mga areas na yun. And then as you go farther from the shoreline, you can observe that there are deeper areas, and sometimes it goes up and then goes down and then goes up and then goes down and then goes up, goes down, goes down. Okay? So ang science ng bathymetry is basically to assess the level of the ocean floor of a certain water environment, no? So gina-assess natin, say for example, these ones here are colored blue, yung mga mabababaw. Itong dito are colored red. Itong dito naman are colored green. So there are variations of a certain color coding, no? May color coding according to the depth of a certain body of water. So ito yung contour natin na tinatawag. Okay? So basically, no? Ang contour is just the topography. Ito yung tinatawag natin topography. Para ang objective kasi ng bathymetry is to show the topography of the ocean floor or a freshwater body. And then bathymetric or hydrographic charts are basically the products or the outputs of the science of bathymetry. Ito yung mga output ng mga sonar or etc. etc. So, ang bathymetric charts involves the production of the ocean and sea maps based on bathymetric data. No? There are agencies that are involved in the production of bathymetric data in different different waters of the Philippines. No? And bathymetric charts also represent the ocean depth as a function to the geographical coordinates. Now, bawat depth, bawat bathymetric data, there are specific coordinates. So that is the coverage, or those are the data that you could see in a bathymetric chart or hydrographic chart as others call it. And then it also typically produced to support safety or surface or subsurface navigation. No? Itong mga NAMRIA, itong mga other offices that are involved or engaged in the bathymetric mapping, sila yung nagbibigay ng information to the PPA or itong mga Philippine Ports Association, and ito yung mga nagbibigay sa mga barko, no? Sila yung nagbibigay ng mga detalye kung saan yung parte na malalalim, kung saan yung parte na mabababaw, in order for them to avoid those shallow areas and avoid accidents. Okay, so that is third. And then fourth is to show seafloor relief or terrain as contour lines. So they sometimes call it isobats or contours, no? May makikita silang contour lines in those areas that are shallower and those areas that are deeper, right? And also, other data that you could provided by the bathymetry is the digital terrain model and artificial illumination techniques. This is used to illustrate the depths being portrayed. No? Ito yung nagbibigay ng detalye also to the depth being portrayed in the chart. And then there are also selected depths for soundings, provide surface navigation information. So ito yung mga detalye that is being produced in the science of bathymetry. Okay, so I hope that's clear. Now let's proceed to this one. What are the techniques that are normally used to assess the bathymetry of a certain environment? So traditionally, before, nung wala pa tayong mga high-tech gadgets, high-tech instruments, etc., etc., ginagamit nila before are sounding lines. Ano yung sounding lines? Ito yung mga just piece of rope na nilalagyan ng sinker or weight doon sa dulo and then inuhulog nila doon sa baba. So as you can see here, may nakikita kayo na ito, rope ito. Okay? So ito, rope ito actually. And then sa dulo ng rope na to, merong sinker. So paano nila mini-measure yung kalaliman ng tubig ng tinatawag natin na certain water or body of water. So basically, hinuhulog lang nila yung rope na may weight and then gina-measure yung rope. That is already a method of bathymetry. Tinatawag natin na sounding line. That is a very traditional method used basically hundreds of years ago. And then another is basically the sonar system. No? We will be defining each one of these, and then later on we will find out what are the advantages and disadvantages of each of these techniques. And then another is sonar techniques. You can see here in this figure, this is basically the sonar techniques. And then another is the radar or CSAT. No? Again, there are advantages and disadvantages of this one. Now let's first take a look at the sounding line. Ano yung advantage and disadvantage of a certain sounding line method of assessing the bathymetry? Okay, so first is the definition of the sounding line. What is the definition? Again, it is a weighted rope or wire that is lowered overboard until it touched the ocean seafloor. No? Inuhulog lang nila yung wire, and then pag na-feel nila na touch na yung seafloor, iniila nila yung rope and then measure how long or how depth is that particular body of water. It is the only way to measure ocean depths for hundreds of years ago. Ito yung pinaka-traditional, no? Even yung mga world navigators before, ito lang yung ginagamit nila to assess the depth of a certain body of water. The disadvantages of this type of technique is basically first is Time consuming, of course. Very time consuming and inaccurate and labor intensive as well, no? Inaccurate kasi, bakit inaccurate? Kasi pag hinuhulog nila yung lubid, minsan natatangay ng alon or natatangay ng current yung rope, and that makes them a little bit inaccuracy or longer than the actual depth of a certain body of water. And then next is shift drift of water currents could drag the line off of that angle, which could exaggerate the depth of the reading. So this is what I was talking about. And then difficult to tell when the sounding line had actually touched the bottom, especially when it was already a very long, no? Kapag mahaba na masyado yung lubid, hindi mo na mapifeel na nag-touch na pala yung weight mo. Right? And that's the first. And then another is, these are the individuals who basically help the development of the sounding line. No? Just a few individuals, you could read this in our handouts. So let's just proceed. And then, another technique is what we call as the sonar. Sonar stands for the sound navigation ranging. Take note of that. Sound navigation ranging. Ano yung sonar? Measures the distances by emitting a short pulse of high frequency sound and measuring the time until the echo is heard. Okay? So basically, ito yung tinatawag natin na advanced or modern way of assessing the bathymetry. It is invented during the World War II of 1939 to 1945. After the war, ships with sonar units attached to their house crisscrossed the world's ocean, systematically measuring the depth of all the waters of the world. The data collected made possible complete bathymetric maps of the world's oceans. No? Ito yung ang sonar, ang dahilan kung bakit meron tayong tinatawag na mga water depths nowadays, right? So, ano yung tinatawag natin na short pulse of high frequency sound? Now, say for example, pay attention. Say for example, this is the water level. Okay? So this is the water level or sea water surface. Or, no. Okay? So this is the water surface. And this is, let me use a whiteboard for a second. Okay, so say for example, this is the water surface. And this is the boat. Okay, so ito yung boat natin. Pasensyahan nyo yung drawing ko. Okay, so ito yung boat. And then, itong boat na to, may naka-attach na sonar device. Itong sonar device, nag-i-emit ng sound waves. Okay, so sound waves, nag-i-emit sila doon. Okay, sound waves, sound waves, sound waves. Sound waves, sound waves, until it reaches to the bottom. So this bottom now basically will be profiled according to the sound wave that is returned or feedback, bounce back to the hull of the tinatawag natin dito, boat or the sonar. So itong sound wave na to, mag-bounce back yan siya, and then pabalik dito, kinakalculate niya yung time, no? Kinakalculate niya yung time, and then i-convert niya yan into a certain depth. Kapag mas matagal, of course, mas malalim. Kapag maikli lang yung time na nagbalik yung sound wave, of course, mas mababaw. And then also, it also profiles a certain profile of the bottom, no? Say for example, itong bottom na to is a type of a muddy bottom of the ocean. So, some sort of recording ng topographic film nito is, ang topographic film is parang ganyan lang yan. So, kapag nag-release yan ng data pabalik, sometimes ganyan, and then ganyan, may malalim, may mababaw, and then may malalim, ganyan. So, kapag may this is a bit of a thick line. Ito yung tinatawag natin na muddy portions, no? Kasi yung sound wave is na-absorb ng mud. Hindi siya directly nag-reflect. So kapag basically yung density ng line natin or yung weight ng line natin basically also dictates a certain profile of a certain bottom. Right? So I hope that's clear. Now let's proceed to another type of a certain, okay, another technique of scanning or another technique of assessing a certain bathymetry. So here we have the side scan sonar. Also sometimes called the side scan sonar, side-looking sonar, sonar, side imaging sonar, and bottom classification sonar. Itong side scan sonar basically lang just assess the bottom of the ocean but also the side part of the ocean. So ito yung tinatawag natin na side scan sonar. Ano pa yung ibang details with regards to the side scan sonar? Side scan sonar uses the device that emits conical or fan-shaped pulses down towards the seafloor across a wide angle perpendicular to the path of the sensor through the water, which may be towed from the surface vessel, submarine, or mounted in the ship's hull. This is what I was talking about earlier, na magre-release lang siya ng sound wave and then goes back and convert the time into depths. And then the intensity of the acoustic reflections from the seafloor of this fan-shaped beam is recorded in a series of cross-track slices. Right? So later on I will show you charts as outputs from this kind of sonar technology. When stitched together along with the direction of motion, these slices form image of a bottom or the sea bottom within the swatch coverage width of the beam. No? Ito yung tinatawag natin na conversion of a certain or profiling of a certain type of ocean bottom. And then the sound frequencies used in side scan sonar usually range from 100 to 500 kilohertz. Higher frequencies yield better resolution but less range. No? Yung mga higher frequencies natin ng mga side scan sonar, better resolution siya pero mas maikli lang yung coverage niya na depths. Okay? So I hope that's clear now. What are the uses of side scan sonar? So, first and foremost is, of course, mapping the seabed. Another is creation of nautical charts. Especially NAMRIA is using already this side scan sonar. Detection and identification of underwater objects. Like for example, yung mga nalunod na mga barko. So, ito yung ginagamit nila to detect and to assess or to survey which part of the ocean floor that was sunk, yung mga boats na yon. And then some of course, especially to those treasure hunters, uses this one to detect also. And then another is to use to detect debris and items, obstructions of the seafloor, and can be hazardous to shipping and seafloor installations by oil or gas industry. So ito yung mga uses nila. Another is on assessment of the status of pipelines, cables on the seafloor. Ito yung mga gamit. And then another also provide a glimpse of the shallow structure of the seabed used for fisheries research, dredging operations, and environmental studies. Also used in military applications using mine detection. Okay? So those are the uses of the side scan sonar. Another, the last type of technique that is used to assess the bathymetry is radar. Radar or CSAT. Produces images by bouncing radio waves rather than sound waves of distant objects. Cannot be used for bathymetry because water will absorb the radio waves. With the use of radar, scientists have already known for the first time that 70% of the Earth's surface really look like. No? Ano yung talaga yung itsura? Ano talaga yung profile ng Earth's surface? So ito yung nakatulong sa pag-profile natin. Okay? So that is radar or CSAT. And then, here we have the term hydroacoustics. Ano yung tinatawag natin na hydroacoustics? Hydroacoustics are generated term for the study and application of sound in water. It is also named as water acoustics. It basically utilizes sonar technology. And what are the uses of this hydroacoustics? So uses are commonly used for detection, assessment, monitoring, and monitoring of underwater physical biological characteristics. and can also be utilized to detect the depth of the water body, like the bathymetry. Can also be used to detect the presence or absence of an abundance, distribution, size, and behavior of underwater plants and animals. So ito yung hydroacoustics yung ginagamit sa mga modern commercial fishing vessels. No? Ginagamit nila ito to detect saan ba yung may mga school of fish, saan ba yung may mga dense population of fish. So doon nila, pag ma-detect nila na nandoon sa unahan, of course, gina-circle nila yan ng mga encircling nets and then harvest. So this is a very efficient way of catching wild sources of fish. And then, here we have hydroacoustic sensing involves passive acoustics, meaning to say listening for sounds. Active acoustics are making a sound or listening for the echo. Hence, the common name of the device is echo sounder or echo sounder. One word or two words. So active acoustics is the echo sounder. Basically, making a sound and then listening the echo of that sound that is already an active acoustics. So what's the typical principle of this hydroacoustic or echo sounding? So here we have a certain diagram or figure, no? So meron tayo dito ang boat, no? So as a certain boat navigates and assess a certain water depth, no? Makikita natin dito na nag-i-emit from here, nag-i-emit siya ng sound wave, and then it basically just converts that into this line, and then as it navigates farther from the shoreline, it also becomes deeper. Okay? So as you could see here in this beam profile. So itong mga beams na to, ito yung mga nire-release ng echo sounding device here and then reflected back and basically converts it into a color matrix or color profile that signifies for a certain depth of a certain area. Okay? So this is basically just the principle of echo sounding. Now, talking about the agencies involving the agencies that are in charge for navigation, for profiling the bathymetric map of the ocean floor are this. Number one is the NAMRIA. NAMRIA, as what I was talking about earlier, is the National Mapping and Resource Information Authority. Or in Tagalog or Filipino, pambansang pangasiwaan sa pagmamapa at dulugang kaalaman. No? National Mapping and Resource Information Authority. Sila yung nagbibigay ng mga bathymetric map, bathymetric charts, hydrographic charts, and etc. etc. So, an agency of the Philippine government under the DENR, responsible for providing public with mapping services and acting as the central mapping agency, depository, and distribution facility natural sources data in the form of maps, charts, texts, and statistics, according to Administrative Number 31 Series of 1988. Okay, so NAMRIA. What are the offices or functions of this NAMRIA? NAMRIA is basically divided into 4 technical departments. Meron din silang 4 technical departments. You can see here, first is the Hydrography Department, another is the Mapping Geodesy Department, and the third is Remote Sensing and Resource Data Analysis Department, and then fourth is Information Management Department. So each one of these has specific functions. Let's first take a look at the function of the Hydrography Department. Ano yung function ng Hydrography Department? Basically, the HD is to acquire and analyze the hydrographic or oceanographic data used for promoting navigational safety, oceanographic research, outputs, and nautical charts, navigational warnings, tides, and current predictions. Sila yung in charge dyan. And then, ito namang Mapping Geodesy Department or MGD, sila naman yung nag-produce and nag-maintain and also updates the base maps that will serve as a basic inputs in various development activities of the government, academic, and scientific community of the private sector. So, sila yung in charge doon sa producing, maintaining the maps, and updating the maps that are released by other sectors. And then itong SR or RSRDAD, they are mandated to conduct and use or conduct land use assessment, evaluation, and land classifications. No, sila yung nag-assess para saan ba tong area na to? Ano yung gamit ng area na to? No, parang resource allocation or tinatawag natin na demarcated areas. Okay? So first function of this agency or department is to provide remote sensing services, vital data on the environment, land use, forestry, agriculture, water resources, coastal zones, and among other datas. And they are also responsible to conduct researches on remote sensing and GIS applications. So those are the functions of RSRDAD. So the last department of the NAMRIA is the Information Management Department. Sila yung in charge on the information security or works towards the sharing, transfer, exchange, packaging, and dissemination of environment and natural resources data. They are also the ones responsible for the development and maintenance of information systems and environment and natural resources databases for not use only within NAMRIA but also outside clients. Like for example, whenever you need certain data from their office, this is the office that you should get into, no? And then serves as a marketing arm of the agency for all its product services, shows the actual maps covered under the alignable disposable lands. Now kapag kailangan niyo ng training on GIS mapping, GPS training, and etc. regarding on navigation, GPS, bathymetry, ito yung opisina na dudulungan nyo, right? So, the IMD or Information Management Department. Okay? So, here we have the bathymetric map of the Philippines. No? You could see or you could take a look at this in a closer picture. No? Makikita niyo ito sa handout na pinost ko sa ating Google Classroom. No? Ito yung bathymetric map of all the seas in the Philippines. The seas in the Philippines are highlighted in red, and here are their bathymetric maps. You could take a closer look of this one, no? In the handouts that I have posted in the Google class. And here are also our the surface area according to square kilometer and average depth in meter of the 24 fishing grounds of the Philippines. Again, you could have a closer picture of this one in the handout that I have posted in our Google Classroom. And next is this one, the locations of the 24 fishing grounds of the Philippines. Take note of this one. Familiarize which part of the Philippines each of these 24 fishing grounds are located. No? Again, take note to familiarize which areas or locations of the Philippine map are these 24 fishing grounds are situated. No? Because perhaps I will be posting one of the tasks that is, or we will have synchronous quiz or tinatawag natin na actual quiz on this one. And then next is the major areas of the world oceans and seas. Ito yung mga average area, average depth, and the deepest part of the certain oceans and seas. So the major oceans are of course Pacific Ocean, Atlantic Ocean, Indian Ocean. According to area, number 1 ang Pacific, second ang Atlantic, and third ang Indian Ocean. According to average depth, first ang Pacific, second ang Indian, and third ang Atlantic Ocean. And the list just go on, so on, so forth. Okay, so those are basically our coverage for this session in this module. So I hope you have already stayed up to this moment, and I hope you have learned something about bathymetry, and I will be posting some of the assessment tasks in the Google Classroom. And again, thank you very much for joining up to this end of the video, and I encourage again everyone to subscribe this YouTube channel for more future videos to be posted. So once again, thank you very much.